Hi, my name is Ryan Granger,
And my name is Jennifer Williams.
and we are covering part one, question four in this video currently with the question.
And our number four question is basically based on the simulations you conducted using the genetic drift simulator and how they change over time. And if it's the population size was affecting it. We discussed it beforehand, and apparently we had different results. On my end, it showed that when the population was much higher, I set it to 80 since we couldn't go up to 100. It took forever for it to asphyxiate. Actually, it went all the way up to like 74 generations, and this lasted for about a half an hour or more. And not one of them went to fixation. The other two that I did was both 10 populations, but they changed between the 2.25 and the 0.75 allele, and they was able to get a fixation a pretty good amount of time. So I had mine as a higher population size would increase the time of fixation. Um,
Yeah, and for me, mine was kind of the opposite, like you mentioned. For me, the really small populations took a lot of generations to eventually hit that fixation mark. Um, Over half my group for the first group, which was the 10 population and the point 0.2 distribution. Um, it took them about 55 generations for most of them to hit their fixation point. In the second group of 10, it still took them around 51 generations, while my much larger group only took about um, 10 to 20 on average, and then one outlier went up to about 32. So we were kind of unsure about this, exactly what this connection was, and we were just thinking that this might be a base by base kind of scenario, that it just depends on who runs it and when it's run, and you get different results just based off of that whole randomness that is there in the world and with genetics especially.
mhm.
We'd like to hear your feedback on this, especially, and see what you all got to, and hopefully we can clear this up a little bit. Thanks so much for listening.
Thank you.